Hello and welcome. This is the second of 4 SkyBox webinar sessions. Today's session will cover SkyBox applications. You're here with Bo McGloin, Senior Product Manager at OutBack Power. My responsibility is SkyBox as well as a few other things. And I'm looking forward to having the opportunity to speak with you today. Please type in your questions at any point that they occur during the webinar, and we'll make sure that we have time at the end of the webinar to address as many of those as we can. If we are unable to answer your specific question today, we will follow up with you via email. And you'll also, at the end of the webinar, receive a link to get a copy of this webinar so that you can review that at your leisure if you like. So again, today's webinar is all about applications of SkyBox. We'll start with a brief recap from webinar number 1 on SkyBox. Then we'll go deep into SkyBox applications. For more resources, you can visit outbackpower.com products, True Hybrid Energy Systems, SkyBox. And for more webinars, you can click on outbackpower.com resources, OPT training /webinars to register for future webinars. Okay, what is SkyBox? SkyBox is a true hybrid energy management system. It provides 5 kW of power in any direction. This particular model that we are releasing now is 120/240 split phase, 60 hertz, so targeted exclusively at North America residential markets. It's resilient, adaptable, simple, and intelligent. And physically, it's a 5-port design. So each one of those points is controllable, and the grid, load, and battery are all bidirectional, allowing for adjustable export or import at any of those locations. And on the load port in the future, we'll support AC coupling. With respect to specifications, it's 5 kW in any direction. 120/240, we covered that already. And maximum AC input power, 240 volts at 60 amps pass through, and that's shared bus across the grid port, load port, and the generator port. The PV voltage window, the maximum power point tracker, goes from 250 volts all the way up to 600 volts. So you should be able to move any existing PV strings over to SkyBox. And the battery voltage window is quite wide and is designed around all of your traditional 48-volt lead acid batteries. Operating temperature range from -20 up to 60, and CEC weighted efficiency PV to grid across the entire PV operating range, 94%. Excellent total harmonic distortion. We do field upgradable firmware. Those are sent over the air, and the homeowner can just click to accept any new firmware updates. All of the SkyBox production data, as well as its firmware, is all saved in non-volatile memory locally on the SkyBox. As well, it can be sent and uploaded up into OpticsRE. And then from an environmental point of view, it's an NEMA 3R, so you can install that outdoors, you can install that on the side of the garage, any place where you have an existing string inverter, you can hang a SkyBox on the wall. So now, without further ado, we'll dive into SkyBox applications and profiles. This particular screenshot that I'm showing is from SkyBox PV production on this particular SkyBox back on May 28th. So it's just what I thought was a cool screenshot of SkyBox. So what are some of the changes in the storage market today? Well, traditionally, you'd see energy storage used off-grid in cases where a home was too far from the utility and you want to do rural electrification, or where you're doing grid tied with battery backup to protect against an unreliable grid, to protect against storms, or provide medical or uninterruptible power supply type loads. And in those cases, you would either size the battery based upon handling all loads, or sizing the battery based upon maintaining power for the duration of the outage, and then staying fully charged in sort of a float mode at any point when the grid was present. And then what's coming into the market today? Well, utilities are changing their net metering arrangements. So they're either making it cost prohibitive for a homeowner to add PV and have a net metering arrangement, or they're not allowing it at all. Also, utility prices are increasing, making storage competitive. Customers want to have on-site energy production and storage for their own energy independence. And then also they're looking to have extra peak capacity for their high use times. And SkyBox addresses all of those applications and is designed with all of those changes in the market in mind. So specifically, SkyBox is designed to reduce energy cost no matter what the utility company throws at you. And it does that in 4 different ways. So the first of those, and we'll cover each of these in more detail later, is time of use energy optimization. The next one that we'll cover is non-export or self-consumption. We'll also cover net metering with battery backup. And then finally, we'll spend a little bit of time talking about maximum independence. SkyBox is set up to work with multiple different profiles depending on what's best for your particular application. And then SkyBox can be programmed to function depending upon whatever the homeowner needs. So with respect to battery sizing and flexibility, SkyBox allows you to size your battery, for example, time of use, self-consumption, and backup. And then you would have different percentages of the battery available for each one of those applications. So you do your daily cycling with self-consumption or time of use, and then you'd have set some reserve. In this case, I'm showing in my cartoon 33% of my battery is reserved for backup. But the important thing to note there is you have full flexibility and control over how you set that up. Okay, with time of use energy optimization, SkyBox will serve loads from PV first, and then after PV, if there is insufficient PV to power remaining loads, SkyBox will use the cheapest power source available, be that from the grid or from battery. And how does SkyBox do that? Well, it's doing that to automate your savings. It's attempting to make life easy for you, the installer, and for the homeowner. You just enter in the data for that particular install, and SkyBox will maximize return on investment. And then we simply do a determination of the lowest cost energy source and then use that. So some of the potential inputs, you'd enter the rate schedule, whether or not export is allowable at that particular location, what your battery replacement cost is as the installer. What is the cost for you to do a truck roll at the end of the natural life of those batteries years down the road? And then finally, how much of the battery you want to reserve as a percent on a percentage basis should be reserved for backup power. Here's a little bit of the math behind that. You look at the install cost, the usable capacity, cycle efficiency, and cycle life, and that gets you your levelized cost of energy, or LCOE, for your battery. Now, this may be the only time you ever see that math. SkyBox will do all of that calculation for you. You just give SkyBox your install cost. And then typically, levelized cost of energy of batteries range between 14 cents per kilowatt hour and 28 cents per kilowatt hour, depending upon the type of battery or how many batteries you install at a particular facility. And then that's just simply compared to, in this case, your weekday time of use rate in San Diego in the summertime. And if the battery is less expensive than your on-peak rate, then SkyBox will use your battery. If it's more expensive than your super off-peak rate, then SkyBox will be allowed to recharge the battery from the grid during the super off-peak time. So pretty simple and straightforward. Here's an example of payback with time of use. So you've got a new PV installation with battery paying for itself in 6 to 8 years. That's up to 2 years faster than a new PV installation without batteries. And you can see the rest of my math there, that this particular home in Sacramento Municipal Utility District, electric bills at this home are going from roughly $330 a month down to $50 a month. Okay, switching things around a little bit, we'll talk about net metering with backup. In this case, all excess PV generation goes back to the grid if the grid is available. One important point on backup is that SkyBox's 5-port design allows you to send 5 kW of power directly to the loads. So that's 240 volts, what is it, 20.38 amps of power direct to the loads. Okay, next we'll cover non-export and self-consumption. And before I do that, I'll answer one of the questions that's coming in live. Kim asked if we can parallel SkyBox for larger power output, 10 kW, for example, for whole house backup. Yes, absolutely, Kim. You can stack up to 10 SkyBoxes together. So you could do 10 kW, 15 kW, 20 kW, whatever was appropriate for the size of the whole house that you were trying to back up, all the way up to 50 kW. And the stacking testing seems to be going well. We've done all the hardware testing to verify that we can support a 10, and what we're working on right now is validating that the software installation and ease of use are smooth and seamless, and we'll release that via a firmware update here in the near future. Okay, so switching back to SkyBox applications or continuing on with non-export or self-consumption. Here's an example from the SkyBox Display. This is showing a SkyBox system programmed for non-export. PV is simultaneously going to loads and battery. And then in this particular case, the generator is on and exercising. And the generator relay is, SkyBox's generator relay is open. So the generator is exercising, but there's still power coming from the grid, roughly 0.4 amps, so less than 100 watts of power being drawn from the grid. But because the grid is present and only one of those two relays can be open, either grid or generator, the generator relay is open at this particular time. So here's an example of setting up the current transducers with SkyBox, and you would attach these at the service entrance. So you'd have a 200 amp or 100 amp pair of CTs connected there, and then that moves SkyBox's point of demarcation for non-export from its grid port out to where the CTs are measuring. So you're able then to send power to the loads that are on the main panel without sending any additional power back to the grid. With respect to maximum independence, This is a trial run for your suburban cord cutters for people to see what it would be like for them to live off grid. In this particular case, SkyBox will open its grid relay. It can still sense current and voltage on the other side, so it knows the grid is present. It will attempt to power all household loads from only PV and battery and only reconnect to the grid when it needs to. So in that particular case, it's still functionally a 5-port design. You're still connected to the grid here, but from a power usage point of view, SkyBox isn't going to close that grid relay until it absolutely needs to. With respect to configuration is quite easy and simple and straightforward. You can choose one of the 4 preset profiles: net metering with backup, self-consumption, non-export, or maximum independence. And then you get time of use energy optimization enabled for you in either net metering or non-export. Your 2 options there on the left. And then there are 2 simple ways to do that. One is through our setup configuration wizard, which launches by default when you install and buy your SkyBox. And then the second way is by doing manual set points by clicking on any one of the 5 tiles from the SkyBox home screen. So to learn more about that, please attend our webinar on November 29th. Our webinar next week will be focused exclusively on hardware installation and hanging the SkyBox up on the wall. So on that note, that webinar for SkyBox installation will be Thursday, November 8th. That's 10 a.m. to 11 a.m. Pacific Standard Time. And then we'll take a 2-week break, and SkyBox software overview will be Thursday, November 29th from 10 to 11 Pacific Standard Times. And you can go to outbackpower.com / webinars to register. You can also go to outbackpower.com / training for the full class schedule and to register for energy storage for the solar professional. This is our industry training course. It covers OutBack Power products, including SkyBox. It's a 4-day course, and then the final 4th day on Friday is exclusively all about SkyBox, and that does provide NABCEP credits. So in summary, SkyBox allows you to take charge of your energy. PV and battery backup are delivered seamlessly from one single box solution. It totally complies with all grid interconnection limitations or requirements. So it's California Rule 21, HECO 14H compliant. It enables time of use, so you can use your PV and your battery when electricity rates are high. It's DC coupled. You can do remote monitoring and updates via Optics RE, and it's compatible with the widest range of battery chemistries, from LG Chem all the way through all OutbackPower.com lead acid batteries and any lithium ion battery that behaves as though it is a lead acid battery. With that, I'd like to say thank you very much for your time. And we'll turn it over to questions. William asked if you get any CE or NABCEP credit for attending this webinar. You do not, William, but you can enroll in the ESSP course, and that is NABCEP. There are NABCEP credits available for that. Michael asked if we have energy tool-based settings. You can have mine, I guess is the best way to answer that question. We've been working with Energy Toolbase and another software supplier in order to provide presets to them, and we'll have those in the future. But in the meantime, happy to work with you on Energy Toolbase and do modeling with you. I've been using that quite a bit and doing quite a bit of work with that particular product. So. Eli asked about SkyBox warranty. Eli, SkyBox comes with the standard 5-year warranty. Kim asked if we can show the locations of the 4-day grid class once again. Absolutely, Kim. I'll go back 2 slides. Those courses are available in Phoenix, Arizona, and our OutBack Power headquarters here in Arlington, Washington, and they alternate. So 1 month it'll be here in Arlington. The next one's coming up next week, November. I have to check the calendar. I know it ends on the 9th, and it starts on that Tuesday. So that must be November 6th through 9 next week. And then the December course is in Phoenix, and then they alternate usually back and forth between Arlington and Phoenix. Ben asked about how does SkyBox comply with NEC 2017 6090.12 rapid shutdown. Ben, the best way to answer that question is to skip forward a couple slides. Okay. So Article 6090.12 B2 addresses PV array safety for firefighters, and there are code cycle differences between the 2014 code cycle and the 2017 code cycle. 2014 said that PV system circuits on or in buildings more than 10 feet from the array boundary must be controlled and down to less than 30 volts in less than 10 seconds. And it left some gaps and uncertainties. For example, how do you define a PV system circuit? And then it originally mandated a 10-second requirement, but that conflicted with the ride-through, so that was later changed to 30 seconds. And then NEC 2017 narrows the boundary to be a 1-foot boundary. This makes a lot more sense. Separate requirements for inside and outside of the boundary. The outside of the boundary is now 30 volts at 30 seconds after initiation of shutdown. And then inside of the array boundary, 1 of 3 options is required. Conformance, having some sort of listed rapid shutdown system that includes the entire array. We're not taking that approach. Performance, limiting the voltage of conductors to less than 80 volts. We are taking that approach. Or construction, having no exposed metal conductors with in or within 8 feet of the array. And my understanding from talking to at least a couple distributors on this is that there are people who are taking that approach and working with their AHJ to work on that. But in parallel, what we're doing on hitting that performance requirement and limiting voltage of conductors to less than 80 volts after initiation of rapid shutdown is we're working with a variety of other companies to certify that their products work, that their NEC 2017 solution works with our products. We've already completed that work with Tigo and the FM80 with ICS Plus, which uses the same hardware and same architecture as SkyBox uses. So we're highly confident that when Tigo starts that testing with SkyBox soon, that they'll find that their rapid shutdown switch works with SkyBox. And we've also done testing with some other companies. I am happy to report that we have completed our IMO fire raptor testing, for example, and that works with all of our OutBack products. And we're working with IMO to produce a letter of a certificate of compliance that states that and that shares those results. So. William asked where SkyBox has been employed and tested. Around the US, William. We've focused on all of our key markets, and we've worked with a variety of installers and gotten it up and running. So we started beta back in April, and it's been tremendously positive, rewarding, and productive experience. And that was a lot of fun too. So Bob asked, the wind generator is exercising. Can I confirm that SkyBox is saving or using that output? When the generator is exercising and grid is present, SkyBox is not using that output. SkyBox has that particular relay open and no power is coming from the generator into SkyBox. Kim, can you clarify your question about the East Coast? I went to school in Rochester, New York, and I have lots of friends and family all up and down the Eastern Seaboard. And while I may live in Washington now, I definitely love the East Coast, and I know that SkyBox does too. Ricardo asked, what's the max current from the grid that can go through the inverter and provide energy to loads? Ricardo, that's 60 amps. There's a 60 amp breaker there. Paul asked if SkyBox could be considered an uninterruptible power supply for the whole house, assuming correct sizing, etc. So for example, would it transfer from grid to battery and not have to reset electronics and computers, for example? So Paul, I wouldn't call it an uninterruptible power supply, but in general, the transfer time is around 20 milliseconds. So we're not seeing the need to reset electronics. We're not seeing the need to, reset the router or change the clocks on the microwave or on the oven. I've been on the phone with a customer when they did this experiment and simulated a grid outage, and all of the computers in their office continued to run and operate for the entire time without noticing that someone had flipped a switch and cut power to the grid. So individual mileage may vary, but you got to think about who OutBack Power is and what we stand for with respect to backup power. We don't want to have the homeowner need to go around and reset any of the electronics or be in the dark for seconds or minutes or longer, right? Benjamin asked if SkyBox can be used in a non-grid tied inverter mode, essentially as a grid connected backup inverter. Yes, it can, absolutely. William asked about the expected update to make SkyBox AC coupled compatible. William, that's my second firmware priority. We are releasing firmware in the near future to support stacking, and then our next major firmware release after that will be AC coupling, and then after that will be advanced load management functionality. We do quarterly firmware updates, and if we don't catch this December firmware update with stacking, then we'll catch it on the next one after that. And so that kind of gives you a feel for where we are with respect to AC coupling. On the topic of AC coupling in a little bit more detail, the SkyBox load port already is enabled, configured to be able to support an AC power source on the load port. What isn't there on SkyBox yet is doing frequency watt adjustment of that grid dependent inverter that would be AC coupled to SkyBox. And it's a 1741 SA world that's pretty straightforward. But again, our priority is to do stacking first, then AC coupling. Oh, Kim asked about training closer to home in New Hampshire, New England, that sort of thing. Kim, I would encourage you to reach out to your distributors that you typically used to buy OutBack Power products. I know that we have a distributor that is looking now to schedule training courses in the Northeast, specifically in Boston and New York, and hopefully that's a little bit more accessible to you out there in New Hampshire. Rob asked for a clarification on rapid shutdown. So with a traditional DC string inverter using an OutBack Power ICS Plus system and RSI, SkyBox is directly compatible and NEC compliant to this solution. Yes, absolutely, Rob. That being said, you wouldn't use the OutBack Power ICS Plus for your traditional NEC 2014 rapid shutdown solution. Because SkyBox is transformerless, the array has to be floating, and so you need two disconnects inside the ICS Plus. So what we've done is we've reworked the ICS Plus for SkyBox and produced a SkyBox rapid shutdown solution that is a little bit less expensive than the ICS Plus. It's about 18% less expensive. So, and Rob, you also asked ground fault detection internal. Yes, absolutely. Arc fault detection internal, and impedance check internal and built into SkyBox. Joy asked a question about generator options, and with respect to SkyBox, we recommend that you use something like a 10 kVA generator with SkyBox. We've tested largest to smallest, and it works great with a variety of generator options. So. William asked a question about Puerto Rico and the ability to clean up grid power with the output. William, I'd like to follow up with you after the webinar to get a little bit more clarity with respect to your question. We've done testing in Puerto Rico with SkyBox, but we haven't, and we've done all of the grid interconnection tests, so it's got all of the PREPA configurations and the ability to set the ride through to PREPA standards built in, but I don't know that we've tested specifically cleaning up dirty grid power and how exactly that would look and how SkyBox would handle injecting volts and VARs back into the grid specific to Puerto Rico. In general, yes, it does that because it's California Rule 21 compliant. But we may not have tested the specifics that you're asking to with respect to your question. I'd like to follow up with you and make sure that I understand it fully. So. Okay, I'm not seeing any more questions, so I think we'll stop the webinar there. Thank you very much for your time. Appreciate you, and it's great talking with you.